Okay, hello. So I'm going to go over the wireless transmission. Okay, first of all, what is the carrier frequency? I'll try and do this in a color that everybody can clearly see. The carrier frequency is 120 kilohertz. Broadcast bandwidth is obviously the whole thing. Base bandwidth is half, broadcast is a whole lot. So obviously in this case, it will be 20 kilohertz. This time, there's an equation on the data sheet. So an AM broadcast is allocated a frequency range 150k to 1.6 megahertz. Obviously, we need to convert those eventually. How many radio stations, having the bandwidth calculated there, can fit? Okay. So first of all, the available bandwidth is 1.6 meg minus 0.15 meg. Okay, so available bandwidth 1.6 minus 0.15 is 1.45 megahertz. Put into kilohertz if you prefer. So 1450 kilohertz. So on the data sheets, you've got the channels, N channel is available bandwidth, 1450 kilohertz, divided by obviously the bandwidth itself. Gives you 72.5. Obviously, you can't have that many channels because it's a weird number. So 72 channels, therefore 72 channels. It's got to be a whole number, not a weird number, a whole number. Frequency spectrum, two channels adjacent. So obviously you've got your main one in the middle. So it looks something like that. There's your main one. Let's do some next to it. So we're going to have one there. One next to it that side, and then one next to it that side. I'll put values on, don't worry. Try and do this as neat as you can. A bit too far, isn't it? Maybe because that hasn't come back far enough. Let's go a bit further around that way. Okay. So in terms of labeling it, obviously you got your 120 in the middle, up by 30, down by up by 10, down by 10. So this will be 120. This will obviously be 140. Can't see that. And this will be 100. So you're kind of going up by 10, down by 10. I hope that makes sense. You might want to label those as well. That would obviously be labeled as 90. That would be labeled as 110, so on and so forth. But that's the idea. So you're showing the channel with bandwidths. And obviously an adjacent channel next to it. So 72 of those will fit onto the station. Determine the frequency of this carrier. Now this one, if you know the audio is 8K, it's quite difficult to calculate this. So the way to do this is to look for one whole cycle. So you go from there to there, count how many of those happen. I know between there and there, you can count yourself. You're getting 19 cycles. So if you've got 8 kilohertz for the test signal, the carrier frequency is higher. How many times higher would it be? 19 is the answer. 19 times 8 will be your answer for that one. So 152 kilohertz. Again, ask me in question. Depth of modulation is dead easy. It's the lowest minus the highest. Remember this one? So you got from there to there. That is 2 volts. The highest is 8 volts. So depth of modulation is, remember, B over A times 100. That's not actually in the notes, but there is an equation on there. But we've always used that one. So B is the smaller bit, the 2 volts. Oh, sorry, yeah, it's the difference between the two. Sorry, so I do the difference. Sorry, between there and there. So it's going to be settled at 5, isn't it? There you go. And that's how I label mine, don't I? Remember, I label that as A, and then from there to the top as B. So in my particular case, B would be 3 volts and A would be 5 volts. Yeah. So 3 divided by 5 times 100, 60%. Yeah. So that's how I do mine. There is an equation on a data sheet if you prefer. I prefer to do that, find a midpoint, and then label them like that. Next one. Amplitude modulated, what we're drawing, frequency spectrum. Oh, this is bog standard. So we've got 150 in the middle. Again, that will do one either side, about there and about there. And then you have to label it. So 150, 165, and 135. Audio. So you can do them as little boxes. You could do one box, or you can do little boxes. Let's do a little box either side like that. Again, 150 in the middle, 165, 135. Okay, I hope that makes sense. You don't need to label 0.3 kilohertz away from there. 0.3 kilohertz away from there. You don't need to do that. Broadcast bandwidth is the total again, so 30 kilohertz. 30 kilohertz. Okay. Right, this one on the mark scheme slightly wrong, so I'm going to do the correct one. Basically, we need to plot 50% depth of modulation. This is where this B over A business comes into practice. So first, we'll find your time period. Time period of the audio. Is it a test signal? I'll call it time period of the test signal. 1 over 10,000 is 100 microseconds. Okay, so that's one cycle to there. B over A, so B over A has to equal 0.5 because it's 50%. So you can use 1 and 2, etc., etc. Quite difficult to see that, but if you go 10 little squares up, that puts you to about there. So that can be the A bit, 10 little squares up. No prizes for guessing what the B bit would therefore be. 5 little squares up. Well done. There's your A. There's your B. One cycle is to there, half a cycle is to there. So it's going to go up to there, down to there. So you'll look on the mark scheme and it's actually done it wrong. They've actually done it as half a cycle. Don't ask me why they get it wrong all the time on mark schemes, but do they do sometimes? So half a cycle to there, finish the cycle off to there. And then you obviously have to put some of these in. So that's one cycle. Let's put a couple in. Couple of cycles in there, so you can see you've got all the working there, and you've shown that it fits inside of there. Maybe do about 4 cycles, something like that. Okay, this next one is exactly the same thing, but with 100% depth of modulation. B over A equals 100. So 100%. Okay, well that's obviously easy to do. So choose nice values. I'm going to go. I mean, the halfway point would be the obvious, but I'm going to go less. I'm going to go here. So I'm not going to use the whole of the of the sheet there. The audio is calculated here. 1 divide 5,000. Equals 200 microseconds. That is the time period of the, is it a test signal again? It's the radio, so I'm going to call it time period of the audio, is that. So that's one cycle. So I've got to go, that's half a cycle, so I've got to go down to the 0 and up to there and down to there. Can you see that's 100%, everybody? Yeah, it's going right the way down if it's 100%. So where are we? So we're going to do exactly the same there. A bit neater than mine, please. You can see I'm not the best at using this. So you can see, again, you don't have to do the this too accurate, but you can see that it would fit in there. Okay. Frequency spectrum. Well, it's blatantly going to be the middle frequency. If you read the question, middle frequency, the carrier frequency, 50K. It's in kilohertz. 1 either side. No prizes for guessing. Up by 5, down by 5. I know it's dead easy, isn't it? What's the carrier frequency of this radio station? 215. Make sure you put units, guys. Don't lose a mark. The broadcast bandwidth. Okay, so again, it's from the bottom to the top. So that's 10 kilohertz. The base bandwidth would be half of that, just so you know. Base bandwidth is from there to there. That would be base bandwidth, if you were to ever ask that. Okay, so if you ever ask base bandwidth, it's from the mid position to there. That should be a B. You can tell that's a B. Right. Frequency spectrum. What is it? It's going to 5 kilohertz. 1, 2, 3, 4, 5. Yeah, so that's basically all that's saying, that there's audio for all of this bit. Yeah, audio for all of this bit here. Okay. Finally, this is dead easy. How would we work out the time period of the audio? Well, we look at one cycle, pick a decent point. I'm going to pick from there because that's pretty much the top to the next time that happens. So it's going between 40 and there's 160, there's 200. Look, we're pretty much halfway in the middle between 40 and 140. Sorry, 40 and 180. So between that is 140, isn't it? So 180 minus 40 equals 140 microseconds. Frequency 1 divide 140 times 10 to the minus 6. Just look at I'll look at my mark sheet rather than do it on my calculator. 7.14 microseconds. Oh, sorry, kilohertz. Come on. Kilohertz. Okay. And then quite simply, what's the time period and frequency of the carrier? So basically count how many waves happen in that time. So how many we got? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So obviously the time period will be a 14th of that. 140 over 14 equals 10 microseconds. And the frequency will be 1 over 10 microseconds is 100 kilohertz. How easy is this, guys? Yeah? Depth of modulation, B over A times 100. Let's have a look where we can find these two values. So where are we going from? About 1.7 up to the peak of 8 volts. So what's the difference between those two? 8 minus 1.7 is that, divided by your 2 is that. So 3.15, about 3.15 volts is the halfway point. So I've got to go up from 1.7 up by 3.15. So I'm going to add 1.7. So 4.85 is my midpoint, 4.85. So about there is my midpoint. Okay, so I'm just going to write that down as A is 4.85. Yeah, and that means B is from that midpoint to the top, isn't it? Which was minus. Where was I again? 8. So I'll just do it again. 8 minus 1.7 equals that divided by 2. It was 3.15. I probably could have done that in my head. Let's make that a bit neater. 4.85 volts. Okay. So you got your B and your A. Yeah. So 3.15 over 4.85 times 100 gives me, divide 4.85. Don't forget there are equations you could use instead of my method, which are actually on the data sheet. There is an equation on the data sheet. 64.9. Let's look at the thing. Oh, look at that. That's bang on. 64.9. On the mark scheme, it says 65%. So my method works really well as well. Okay, that's all the AM stuff in a nutshell. Your next video will be on the FM stuff. Okay, I hope that makes sense for your homework. Please ask me. Don't just leave it. Ask me any questions that you may have going over these bits. Okay, thank you very much.